All right, so in this module, we're going to look at some examples of polymer crystallinity. So we're going to do some worked examples of what we learned in the last module. All right, and so these will all be on the quiz if you have one for the week. So you can go there. If not, I would just recommend doing this on a piece of paper or whatever you have. So the first question I want to ask, and you'll see this type of question in the book as well. So I'm trying to kind of give you a taste for the book problems in terms of how they ask questions, which can be a little bit interesting. So, but what I want to ask on this one is, I'm giving you two different types of polymers, and I want to know if you think it's possible to determine which polymer is more likely to crystallize. And if you can tell that, then which one is more likely to crystallize, and kind of give your explanation. And so, excuse me, for each of these, I give kind of the structure. So the first case here is linear, the other one's cross-linked, and then maybe some tacticity or transis properties. So this one's isotactic, and it's polypropylene. So I give you the repeat unit here. And the same thing with this next one. It's cross-linked, it's trans, and it's polybutadiene, so kind of a rubber. And so you get the repeat unit here. So using this information, all of these factors between these two polymers, see if you can determine if it's possible to tell which polymer is more likely to crystallize. And then if it is, tell me which one, and then give me a brief explanation. So see if you can do that. Again, if you have a quiz there, do that. If not, just do this on a piece of paper. Pause the video, and then we'll come back and we'll work this one together. All right, so let's take a look at this question and which one is more likely to crystallize, or if we can tell. So what I like to do on these types of questions is kind of work factor by factor. So kind of compare linear and then the structure. So compare that to cross-link. So if I compare linear and cross-linked, right, we know that linear is much more likely to crystallize. So that factor alone would favor the first polymer, the polypropylene. But we have to look at the other ones too. So let's look at the second factors, trans or isotactic. So isotactic is very regular, so we know those are more likely to crystallize. And then trans here, that means that they're on opposite sides, right? So the units here are on opposite sides of the double bond. But that's very regular as well, right? So if they're always on opposite sides, that's a regular arrangement. And then we can actually look at the repeat unit itself, so polypropylene or polybutadiene, right? So polypropylene is a vinyl polymer with a CH3 group. And so we know those to be fairly flexible, and this can impede a little bit based on CH. But over here, we have a carbon-carbon, but there's a double bond, right? So double bonds negatively influence the flexibility, right? So here we've got a couple factors that seem to indicate that this one would be more likely, right? So linear versus crosslink would favor polypropylene, and then the repeat units themselves would favor polypropylene versus polybutadiene, right? So that's what I kind of get out of this one, is that there's a couple of factors, and the other one kind of just is negated. Factor influence polypropylene. So linear chains and isotactic increase regularity, while cross-linking decreases it. And again, you see the repeat unit itself can also do that. So here, I think we have enough evidence to say that the top one, polypropylene, linear and isotactic polypropylene, are more likely to crystallize compared to the cross-linked trans polybutadiene. So you have to look at a number of factors, and there may be conflicting information, and so you might not be able to tell on some of these types of questions. So that's why it has the first question of, can you even tell? All right, so let's look at another example then, and let's look at same type of question and same same type of question, same general types of polymers, but let's ask the same questions. Can we determine which one's more likely to crystallize, and if so, which one and why? So the first one is going to be linear and isotactic PVC, polyvinyl chloride, and then we have linear and atactic polypropylene. And I'm giving you the repeat structures on both of those. So see if you can tell on this one. So pause the video, come back, and we will discuss. All right, so let's take a look at this one and see if we can tell. So linear, they're both linear, so that factor doesn't influence anything. However, the tacticity does, right? So isotactic is more favorable than atactic, so that would indicate the polyvinyl chloride. However, if we look at the repeat structures themselves, we notice that the Cl chloride group was very electron rich and affected the glass transition temperature heavily, right, compared to the CH3 group. And so that would indicate it's less likely to crystallize relative to polypropylene. So basically, these N groups would favor CH3. So that means that CH3 makes it more likely, but the atactic makes it less likely, and the vice versa here, isotactic versus the chloride. And so in this case, we have two factors that are going in opposite directions, and we don't know the relative effects that they have with the information in front of us. And so in this case, I would say that we don't have enough information, right? Because this would make it more likely to crystallize, but it's atactic, which is less likely. And then isotactic is helpful, but the Cl makes it less likely. The presence of this polar group, the very electron rich, makes it less likely. So we don't know which factor helps the most. And so we can not say in this case. And so we would have to have more information if we were trying to solve this problem. So that's kind of a couple examples of the problems that you tend to see in the book. And, again, we're kind of looking at relatively which one would be more crystallized in these types of problems. And so you have to look at all the various factors that we talked about, potentially chain length, types of N groups, flexibility, all of those things kind of go into which one of these is going to allow us to tell.